Hello everyone. In this video, we're going to learn about systems of equations. First definition, system of equation is simply a system that has two or more than two equations with the same variables. So if I have two equations, I should have x, y. You have three equations, I should have x, y, and z, so on and so forth. Now, there are different ways to solve that, just like when we solve one equation. Remember, we first solved it with graphing, then we solved it with algebraic method. Same thing here with systems of equations. The point x, y, where the two lines intersect, is where the solution is. Algebraically, that point where the lines intersect is the value that makes both equations true. So I also at this point I want to remind you that remember, if this is too fast, remember to pause, write down the notes, rewind, and rewatch that portion that may be too fast for you. Now, there are three types of solutions when we solve for systems of equations. The first kind is when the two lines intersect, just like the way it is here. I've got two lines here, and they intersect at one point, and therefore I have only one solution. But if I have two lines that parallel to each other, they do not intersect, and therefore there's no solution. We use that symbol. It's called a null set. And the third type is I have the same line, and then I have one line, I have a blue line, and then I have a yellow line on top of the blue line that completely overlaps each other. And that's when we have unlimited solutions to it. So unlimited, we just use a infinity to express that. So again, there are three types of solutions. One solution when they intersect, no solution when they parallel, and infinite solutions when they overlap. Then they are the same lines. So next, let's look at how do we solve these systems by graphing. As we reviewed previously, to graph any equation, the first thing we need to do is to rewrite the equations in slope-intercept form, which is y equals mx plus b. That's slope-intercept form. When we graphed one line, we just did it once, and now we have systems. We just do it however many equations were given. And next, we graph the line. Remember, how do we graph the line? We need to find b first, and then graph 0b. Then we find m, which is rise over run. And as I stated in class very often, rise is always positive because nobody rises down. We always rise up. But run can be positive when we run to the right, can be negative when we run to the left, right? So then the third step is to identify the solution or the intersection. Identify the solution, or in solutions when they overlap, right? Solutions. So let's look at number one. Number one, it's very nice because the equations are already in slope-intercept form. So let's graph the first one. I always like to write the equations down first. So I'm going to use blue. The b is -8. The slope m is 1. So I'm going to rewrite that into an equation. So I find 0, -8. It's right here. 0, -8. It's on the y-axis because it's the y-intercept. Intercept meaning the line cuts it right there, right? Then I go from that y-intercept. I rise by 1. I run by +1 to the right. So now I have 2 points, and therefore I have the line right here. It goes on and on forever. That's the first line. Now I will use a different color. Look at second equation, y equals negative 2x plus 1. So in this case, my b is positive 1. My m is right in front of that x, which is negative 2. So I'm going to rewrite it into 2 over 1. It's a rise over run. So in this case, b is 1. So 0, 1 is where the y-intercept is. And from that point on, I go for my slope, negative 2 over 2. So I rise by 2. I run to the left because it's negative 1. I run to the left by 1. And now if I graph that line together, I have to move this over a little bit because it's not on the, there we go. There we go. Why is it not moving? There we go. That's on these two red dots right there. So the red line and the blue line intersect at one point here. And that one point looks to me as 1, 2, 3 here, 1, 2, 3, 4, 5. That's negative 5. So, oops, 3, oops, my apologies. 3, negative 5 is the answer. Sorry about my bad handwriting. Right there. Positive 3 and negative 5 is my final answer. Is where the intersection is. So let's look at number 2. Same thing. I'm already given slope-intercept form. So first step is taken care of. Now in order to graph the line, I need to know my b. I need to know my m. My b is 9, therefore 0, 9, which is right here. And then from there, my m is 1 over 2. So I rise by 1, I run by 2, which is right here. These are really high up there. So now I connect the line, the dots. Oops, those are not exactly on the point. So I have to move this a little bit. Move this over, that's a little off. So it really has to be precise, otherwise it's hard for you to find the right answer, or it's impossible for you to find the right answer. Now let's look at the second equation. I have y equals negative x plus 6. So my b is 6, my m is negative 1. There's an invisible 1 there, and I'll write that into a fraction format. So 6, I have 1, 2, 3, 4, 5, 6. And then I rise by 1, but I run to the left by 1 because it's a negative. And now I connect the dots. That's pretty good, actually. That's quite perfect. And you can tell the intersection is right there. I should use the blue. The intersection is right there. Or I'll use the black just to highlight it. Okay? Once I find the intersection, that's my answer. And it looks to me, the x value of that is right here. So that's negative 2. And the y value is here. So that's 8. So negative 2 and 8 is the final answer for number 2. So let's look at the third problem. These are standard forms. These are not. If you get too tired at this point, feel free to take a break, but I'm going to go on. So press pause and then come back to it later. Okay. Number 3. And number 3 is called standard form. Look at the x and the y are on the left-hand side, the same side of the equation, rather than straddles different sides, right? So I am going to rewrite this into slope-intercept form by getting rid of that x term and by doing the opposite inverse operation. And in that case, I have 3x plus 8. Now I know my b is 8, my m is 3. So I'm going to go for 8 here. That's my B. And then I rise by 3. So I rise by 1, 2, 3, and I move to the right by 1. That's my first answer. That's the first line. Now the second line is negative x plus y equals negative 2. So to get rid of the x term, I do the opposite. I have y equals x minus 2. So in this case, my b is negative 2, my m is 1. So b is negative 2 on the y-axis is right here. And then I rise by 1, I run by 1. So now if I connect this, all right. Now that blue line is not long enough, so I have to extend that line. Did I get this right? Yeah, it's a little bit like that, right? I think that's about right. The red line is pretty good already. Maybe a little bit up, actually. It's a little up. Right there. That will go through the 2 red dots there. That looks pretty perfect. And so now if I look for the intersection, it's right here. And if I read this coordinate, 1, 2, 3, 4, 5. So that's negative 5 right here. And then this is negative 7. So I have negative 5 and negative 7 there. Note that these problems are carefully selected so that you have the intersections right on the grid. Sometimes it will give you a fraction, and that's why it's important to graph them precisely so that the intersection is right on the grid. Okay, let's look at the next one, number 4. Again, standard form, so I'll take the first equation and I have to write it in slope-intercept form by getting rid of the x term. So I end up having 2y equals negative 4 plus 2. And remember 2y, I have to divide 2 on both sides. And now I am going to split this. Remember, we have to break our heart, unfortunately. So I have negative x over 2 plus 4 over 2. If I further simplify that, I would have half of x plus 2. So now the b is 2. b is 2. m is negative 1/2. So b is 2 is right here. Then I rise by 1, positive. Then I run negative to the left. So let's see if I can connect these two carefully. Yep. And now the next one, I'll go a little faster on the second one. The second one, oh, how nice. The second one, they already gave me the y-intercept form. But look what's happening here. My second one here and the first one I manipulated are exactly the same equation. In other words, I have a green line overlapping the blue line. And because they overlap with each other, they're exactly the same. So in this case, I have infinite number of solutions. So now I want to look at number 6 because that's another special case in addition to 4. The first equation is already written in slope-intercept form. So I have 5. 1, 2, 3, 4, 5. My b is 5. And my m in this case is 1. I'm not writing it out, okay? So I'm rising by 1, running by 1. And that's how I get my first equation, and therefore the first line, roughly. It's a little off. I'll fix that later. Now let's look at my second equation. I have x minus y equals 2. And we said I'm going to get rid of the x by doing the opposite. And so I have negative x plus 2. And then remember the trick I taught you. If I change the negative y to y, I have to make sure that I change all the signs in every single term on the left-hand side and as well as the right-hand side. So now I have -2 as my B intersect. And then I rise by 1, run by 1. So that's my second point. There we go. Voila, look what happens. I need to fix it just a little bit, right? I think the blue line is not quite lined up. Why is this not moving? There we go. No, it's more. There we go. Okay, now that's more obvious. Clearly the blue line and the red line, what do we call this? They parallel to each other. They do not touch each other. So they can keep going on and on and on and on. They do not touch each other. Therefore, there's no solution to this. If they don't intersect, there is no solution to it. So let's come back to look at number 5. This has one of the special cases. So let's see. The first equation is x plus 3y equals -15. So I will get rid of the x term. I have 3y equals -x minus 15. And now if I divide both sides by 3, I have y equals -x minus 15 over 3. And remember, to split a fraction, you have to break a heart. And, oops, let me erase that. So now you have -1/3 x minus 5. So minus 5 is my b, and that's right here. That's -5. And then from there, I rise by 1. I run to the left by 1. And here we go. Here's my line. I'll come back and fix this. This is not quite on the line. I'll come back and fix this later. And then let's look at the next one. I have just that. So remember, how do I match that with y equals mx plus b? So I'm going to write it here, okay? So to match that, I don't have an x term, which means my m is 0, and then my b is -7. So -7 is here. Then if I don't ever rise, 0 divided by anything is 0. So that means I have a line that's like this. Because that's the rise is 0. But the denominator can be anything. Okay, so this is a little harder to comprehend. So try to understand that. If not, we'll do more practices at home, in class. And let's see. So they intersect right here. I want to say that's 1, 2, 3, 4, 5. So I have 5 on the x. And then I have 1, 2, 3, 4, 5, 6, 7. I have -7 on the y-axis. So that's my answer there. Now let's look at the last two functions, last two equations. So 3x minus 5y equals -35. That's a standard form. So if I subtract 3x, right, I have -3x minus 35. Now if I divide -5 on both sides, and then I would have -3x. I'm just going to split it right now. And then plus -35 over -5. Notice how I split the negative numbers, okay? If I simplify this, double negative gives me a positive, double negative give me a positive. So I have 7 here as my b. And then I rise by 3. 1, 2, 3. I run by 5. 1, 2, 3, 4, 5. And therefore, I have my line there. Okay. Now, let's look at the red one. I have 2x plus y equals negative 6. I subtract 2x on both sides. I would end up with negative 2x minus 6. So 1, 2, 3, 4, 5, 6. That's my b, negative 6. And then I run by 2. I rise by 2. I run by negative, run by negative 1. My apologies. Because this m is negative 2, which is negative 2 over 1. So I rise by 2, run by negative 1, and then I draw the line here. So if I fix this a little bit, I fix this by extending this, right? You can see the line intersects around here. So I should make it black around here. And it looks to me that's 1, 2, 3, 4, 5, 6. So I have negative 6, and I have 1, 2, 3, 4. I have positive 4 on the y. You know, make sure it's hard for me to draw on the iPad with precision. So when you draw it on paper, you may be a little different. You may have negative 5, 4 rather than negative 6, 4. That's okay too. At this point, I'm not looking for precise precision. I obviously do look for it, but I understand that we all have our limitations when it comes to technology and all of that. Okay? Last one, here is another special case. X equals negative 2. Remember when it's x equals negative 2, if you remember my Algebra 1 class, probably the best way to describe it is that this is undefined, meaning at x equals negative 2, which is right here. That's where x equals negative 2. If you've heard my story of how I fell off the cliff when I was skiing, this is the line. Oops, that needs to move over a little bit. This is the line that looks like the cliff where I fell off. It's undefined, right? It's basically Death Valley. So just remember that when there's no y, that line cannot touch the y-axis at all. Now, let's look at the second equation, negative. So I have to rewrite that again into slope-intercept form, y equals mx plus b. And then I divide negative 2 on both sides. I will have negative 3x minus 18 over 2. Remember, this is where I split the heart. Make sure over negative 2. Make sure you carry all the negative signs. Do not drop it, like I sometimes do, bad habit. Double negative now makes a positive 3 over 2x. Negative 18 divided by negative 2 is positive 9. So positive 9 is my b, my y-intercept. Now I rise by 3. If it goes beyond that chart, you just keep graphing, because remember, this plane just keep going on and on and on. And then you connect the dots. Once you connect the dots, you will, then you will see where they intersect. It's right here. So that looks to me is negative 2, and that's 7, right? Is that 7 or 6? 1, 2, 3, 4, 5, 6, 7. The answer key said 6, but I graphed 7 on my iPad, so it may be just some Again, the technology is messing with me. Your paper may say -2 and 6. So I'll look at your graph. I'll make a determination then. All right, that's it. I will see you in class soon. Take care. Bye.